Hi, welcome to this video, and in this I'm going to go through question 1 from the A2 November test. So it starts with an investigation into a reaction, and 1A asks you, explain why the absorbance decreases during this experiment. So all the way through, it starts at 0.8 at 0, after 600 seconds the absorbance 0.05. And you needed, in this 2 parts, generally people only put 1 part in. So you had to make clear that iodine, or I2, has a yellow or orange colour. Then you need to say the concentration of I2 decreases. So you're pointing out the reason why absorption is going to fall is because if concentration decreases and I2 has this yellow and orange colour, as the concentration of I2 decreases, this yellow and orange colour disappears, and therefore the absorption drops down. And that was needed both of those for the mark. In part B, you had to work out the concentrations of I2, firstly at 0 seconds when absorption is 0.80, so right at the beginning. You had to work out the concentration, and then at 500 seconds it tells you it's proportional. The absorption is proportional to the concentration. You then had to work out what the concentration of I2 was after 500 seconds. This is concentration of I2. So generally people saw what the initial concentration was of the I2, and they went for this, well, I've got 1 mole per decimetre cubed, so this must be 1 mole per decimetre cubed. But that's not the only thing that's in the mixture. We also, there's 1 centimetre cubed of this, but we've also got 49.5 centimetres cubed of the propanone, and there's 49.5 centimetres cubed of hydrochloric acid. So that's a total of 100 centimetres cubed. So we have a concentration of 1 mole per decimetre cubed in, and 1 centimetre cubed of this, but now it's been dissolved into 100 centimetres cubed. So it's dropped down by 100, it's been diluted by 100. So the concentration is now not 1 mole per decimetre cubed, it's been diluted by 100. The concentration up here is now 0.01 moles per decimetre cubed. Well done if you spotted that. In part 2, or the second part, tells us it's proportional. And one way we can look at this and say, okay, well, if it's proportional, then 0.01 over 0.80 will equal our missing concentration over 0.18. And if you times all that out, so times both sides by 0.18, so we'll have 0.01 times 0.18, and then divide that by 0.8, we get then our concentration up here of 0.00225 moles per decimetre cubed. There are other ways to do this calculation, that's just the simplest way that I like to do it. In part C, we needed a graph, and you got 3 marks for your graph. The first mark was for having the axis label with units and linear scales, and at least half the graph paper used. So most people just used the full section of the graph paper. So you had 0 to 600 along the bottom, and then absorption 0 to 0.8 along here, all the way up to the top of the graph paper. This then is time in seconds, and here we've got our absorbance, which doesn't need any units. Then you plotted your points on. If you plotted your points all correctly, you got a mark. So that's your second mark on here. And your third mark was for having a straight line of best fit. So that was generally quite an easy 3 marks there. Then one part C, it asks you what the order is here and explain your reasoning. So looking at the graph, if it's a straight line, then the order equals 0. And we know this from a straight line. If I just draw a quick one, got time and absorbance, because at no point, as concentration is decreasing, does it change the rate at which it decreases. So you'd expect if it had first or second order, as concentration decreases, that would have an impact on how fast then the concentration is decreasing. It either, as it decreases, it will get slower and slower and slower. But this has no impact on time because it's a straight line all the way down. So the order is 0, and we can say that the rate doesn't depend on the iodine concentration because time's not changing as concentration decreases, but straight line shows it's constant. Is how I'd answer it. All the way through. Doesn't change how fast the reaction goes. In step D, we've got a 3-step mechanism that's been proposed for this reaction. So in step 1 is our slow reaction. So in this, because we look at step 2, we know the finishing product in step 1 has been shown to us. It's this weird double bonded oxygen with a single bond, which makes it positive then, and then CH3. So we need one of the things we know that actually affects the reaction. So we know our iodine's not going to be in here because it's 0 order, so it won't be in the slow step. So it's whatever else is left here for us, and we know we've got CH3, CO, CH3, and this was the tricky bit, realizing that what else did we have here? And again in step 2 there's a bit of a clue here. So in step 2 we get a product that is H plus ions. Now H plus ions aren't in the overall equation, so they're a catalyst. They needed to have been added somewhere, and this is where they get added. It is our hydrochloric acid really that we added. There was 49.5 centimeters cubed of hydrochloric acid, so that was an acid catalyst. So we're going to have H plus here, and our propanone plus H plus goes to this weird hydronium type structure. Then in step 3 we know we've got our H plus are now cancelled out, so we don't need to have H plus here, but we are going to take our product from step 2, this hydroxypropene, and now we've probably noticed in step 1 we didn't have iodine added, in step 2 we didn't have iodine added, so in step 3 we've got to, because it's in our overall equation. So we're going to have our iodine now in here, and that is going to form our product, which is, I'm not really drawing that correct, it should go to the carbon, not the hydrogen. So our product there, CH3, CO, CH2 with an I on the end, plus we've lost a hydrogen from this alcohol group, so we're going to get hydrogen iodide, which is our other product. So we've got our 2 products then there as well, and the whole reaction's complete. And that is question 1.